Hello, Chris McLendon with CrystalVision. I'm going to take you on a quick tour of our new MARBLE-V1 media processor. Marble is our new shared hardware platform that runs a variety of software apps. It is powered by a GPU-CPU processor that runs Linux with a CrystalVision operating system layer. MARBLE-V1 has a 10 gig per second throughput that allows for multi-flow processing. It has 6 bi-directional SDI and 4 10 gig physical network interfaces. Inputs and outputs are customized by the installed app. Marble utilizes PTP as well as analog references with failover protection. All apps can use a mix of SDI and IP inputs and outputs with both SMPTE 2110 and 2022 support. The only exception is our gateway apps that have their input and output protocol determined by their gateway function. So let's take a look at the control blocks of our Marble processor and our Vision Web browser-based control. This is our Vision Web control for a MARBLE-V1 loaded with our MCoco2 color corrector app. You'll notice the Coco app processing tools occupy the first two positions of the control menus. One of the great features of Marble is that the installed application sits on top of the common hardware, meaning that a Marble card runs an app that is currently loaded but can have another app loaded as needs change. This is a great future-proof feature that allows Marble processing to grow with your facility. The shared hardware software app approach allows us to customize solutions and make custom apps for specific needs. Each Marble hardware has the following configuration tools: presets, flow in, flow out, references, Ethernet interfaces, and defaults. Let's do a quick tour of each of these configuration tools, starting with the Ethernet interfaces. The Ethernet interfaces menu allows for the manual configuration of each of the 4 physical Ethernet connections. These 4 connections can assist in network design to isolate networks where protect flows are used. Looking at interface 1, you'll see each physical connection have 6 individual addressable connections. Each interface fully supports VLAN and shows status of its connected link. Once interfaces are properly configured, then it's on to flows, starting with flow in. The installed MCoco2 is a dual flow device, so you'll note that there are 2 configurable inflows for this app. As noted before, inflows and outflows are customized by the Marble app installed. Getting started with the status menu, you'll see all of the signal status of flow 1 and flow 2. Here, flow 1 is present and displays format, and then if there are any errors. In this example, video is frozen. Audio status shows you the audio groups that are present for inflows. Let's have a look at flow 1. Under flow, you can enable the flow, set the protocol utilizing either SDI, 2110, or 2022 protocols, identify a flow with an SSRC, and set the format for a 2110 inflow. Network in sets the interface to be used and allows for a unicast or a multicast address to be entered for source material. Protect network in allows for a protect flow setup if you've selected a protocol with a protect signal routing. Below flow 1, you can look at the network stats for this input flow. These statistics can help with network confidence and troubleshooting, showing things like percentage of protect packets being used, lost packets, and gaps for both main and protect flow. Flow 2 would also be configured for this application following the same steps as previously described. With flow in set, now let's go and look at flow out. Flow out statuses are shown in the first menu. Flow 1 configures outflow 1. Under flow, you enable or disable the flow, select between SDI and IP protocols, noting that Marble supports both general packing mode and block packing mode. Source and format are specified. This flexible routing allows the flow out source to be set for any of the inflows. This is useful if you're wanting to configure the app as a single inflow device with multiple independent processed outflows. You then select what you want the output to do in the event of loss of input, and also select an output test pattern if desired. Up to 10 frames of output delay can be added to the output to assist with overall system timing. SSRC can be added for downstream flow identification. And finally, output traffic shaping can be employed for outgoing 2110 packets, selecting from linear, gapped, and burst mode. Network out allows for the selection of Ethernet interface and destination port and address to be configured. Time to live for this signal can also be set here. Protect network out allows for the same configuration of a protect flow if the protocol selected includes a protect flow. With interfaces configured and inflows and outflows set, let's move on to references. Reference status shows the status of the connected and configured references. PTP connections are via the 10 gig media network, and reference 1 and 2 are analog references connected to the vision frame. The configuration menu allows you to set the primary source for reference as well as a failover hierarchy. Output timing is used to set a reference offset using the cumulative time set by these sliders. The PTP menu is where you set the master and backup PTP clock utilizing a selected interface on the media network. And finally, PTP statistics show the network statistics of the configured PTP clocks. Presets allow you to store and recall up to 16 presets of all configurations of the Marble board and installed app. These presets can be useful when recalling different processing settings as well as different inflow and outflow routing. This is especially helpful if an overall control system is not in use. The defaults menu allows you to reset the card to factory settings, either including or excluding stored presets. Status delays is for you to set a delay in seconds before alarms occur in the board status sections that show alarms. This was a quick tour of our MARBLE-V1 media processing platform. Please let us know if you'd like more information about our Marble platform or any of the available apps. Thank you for watching.